So here we want to express this vector here, 4, 7 and minus 2, as a linear combination of these three vectors here. Now what we want to do first of all is to check that each of these vectors are not multiples of each other. So you can see quite clearly that this one can't be a multiple of this one because of the minuses, and similar kind of thing going on here. And this one with this one, that can't be either. So they're not multiples of each other, these three vectors here. Now what we want to do is do a little setup first for our linear algebra question, is to express this vector here. So we've got the vector 4, 7 and minus 2. Now this here, I'm going to call that vector 1. So I'll call this vector 1, call this vector 2, and that one vector 3. So our setup is we want multiples of these three vectors to make it into this. So our scalar multiples, and that's legitimate, that's what we can do. We can multiply them by alpha, beta and gamma. So we've got alpha 2, 4, 5 plus beta times 1 minus 2 minus 3, and then plus gamma 3 minus 4 and 7. So that's what we want to do first. That's our setup. Now one thing that's important with these three vectors here as well is they must go through the origin. So this vector here also will go through the origin, and all three of these vectors are on the three-dimensional plane. So it's very important that they're all in three-dimensional plane. Okay, now what do we do from here? Well, this here is just going to set us up three equations. So what I can do, because multiplying vectors, with this being a scalar, I can multiply this scalar by each of the numbers inside, and same here, and same with this gamma, I'll multiply by each of the components inside each of vector. So now I can break apart each of the three vectors. So now I can set 4, that will equal 2 alpha plus 1 beta and plus 3 gamma. So that's our first setup there from the x coordinate. Now the y coordinate is here for 7. So therefore then that would equal alpha times 4, so that's 4 alpha, beta times minus 2, so I'm going to put minus 2 beta, and here I've got minus 4 gamma, so minus 4 gamma. And the same with the z component, minus 2, that will equal 5 times alpha plus beta times minus 3, so that's minus 3 beta, and this one here gamma, that's going to give me 7 gamma. So to find our scalar multiples of vector 1, 2 and 3, we need to solve for our alpha, beta and gamma from these three simultaneous equations, and then we can put them in there and hopefully they will give us our resultant vectors. Now with these questions you have to limit a confidence sometimes, is because sometimes this alpha, beta and gamma, although they are in the real numbers, you might get some crazy looking fractions in there to make it work. So always have confidence and then check your answers at the end. So that's what we're going to do here today. So first of all, how are we going to solve this? Well, Gauss elimination would be one method. Here I will try the substitution method because I've got beta on its own here. So this is equation 1, this is equation 2, that's equation 3. If I can isolate beta and then plug it into these two, then I'll have two equations with two unknowns, and that'd be nice and easy for us to solve in simultaneous equations. So let's have a look at that. So I've got beta here, so let's isolate that. So I'll have beta will equal, so get everything onto this side. So I've got 4, the 2 alpha can come across, so that becomes minus 2 alpha, and the 3 gamma also can come across, so that's minus 3 gamma. Now what I can do now, as I've got a beta here from equation 1, I'm going to plug that into equations 2 and 3 and see where that takes me. So that's my setup, and then that's my B isolated. So now what I'm going to do is I'm going to plug that into 2 and 3. So now I'll have 7 equals 4 alpha minus 2 times beta, which I know is this. So that's 4 minus 2 alpha minus 3 gamma. And then, not forgetting, minus 4 alpha. So minus 4 gamma, not alpha, 4 gamma. Okay, now next one, what am I going to do? Well, I've got this one here, minus 2, 5 alpha. So I've got minus 2 equals 5 alpha, and then minus 3 times beta, which is 4 minus 2 alpha minus 3 gamma, and then plus 7 gamma. Okay, let's just simplify this up a little bit and get the matching alphas and gammas together. So we do that with both of these. So this is 1a, and this is 2a, and this is 3a. Okay, so I've got 7 equals 4 alpha minus 8 plus 4 alpha plus 6 gamma minus 4 gamma. So that's 2a simplified off a little bit more. And then here I've got minus 2 equals 5 alpha minus 12 plus 6 alpha and plus 9 gamma plus 7 gamma. And that's equation 3a. Okay, right. Now let's just simplify off a little bit, get all the bits together. So add 8 to both sides for 2a. So now let's write 2a here because this is the bit I'm going to use. I've got 15. 4 alpha plus 4 alpha is 8 alpha. And 6 gamma minus 4 gamma is 2 gamma. Okay, so that's looking a bit more like just two variables. So minus 2, add 12 to both sides, so I'll get 10 equals 11 alpha. 9 plus 7 is 16 gamma. Okay, so that's 2a and that's 3a. So now let's get a matching variable with the same coefficient. This 2 to 16 looks straightforward. I could do the gamma, but it means multiplying both. The alpha. So I'm going to do the gamma. So I multiply this one by 8. So 2a times 8. That's going to give me 120 equals 64 alpha plus 16 gamma. Okay, so now my 3 alpha, so for my 3a and 2a times 8, I've now got the 16s. So if I just take these two and subtract them. So let's do a subtraction. Just ignore that bit, that's just my names. Okay, so now I've got 10 minus 120. That gives me minus 110. 11 alpha minus 64 alpha gives me minus 53 alpha. Subtract those two, they're going to disappear. So now to get alpha on its own, I divide both sides by minus 53. So that's going to give me alpha equals 110 over 53. So that's my first variable that I've got. So now let's plug that into one of the other two, and then I can get my gamma. So let's plug that into here. So let's go 10 equals 11 alpha. So 11 times 110. Well, 11 is 121. Stick a 0 on 1210 over 53 plus 16 gamma. So now I can solve for gamma, only one variable in there. So let's go careful here. If I make this over 53, I need to multiply the top by 53. So now I've got 530 over 53. So that equals 10. Subtract this 1210 from both sides. Minus 1210 over 53. That equals 16 gamma. Okay. let's go careful here. 530 minus 1210. Well, the difference between those is going to be, well, to 1000 it's 470 plus 210, 680. So it's minus 680 over 53. So minus 680 over 53. Okay, and that equals 16 gamma. So what does gamma equal? Well, divide both sides by 16. So let's do some calculations here. 680 divided by 16. Okay, 16 into 68 go 4. And it's going to give me 4 left over. 16s into 40 go 2. And going to give me 8 left over. And then we got a 5. So 60s into 680 go 42.5. So if I double the bottom, I can then get gamma equals 42.5 times 2 gives me 85. And don't forget it's a minus sign. And then double the bottom, 106. Minus 85 over 106. That gives me my gamma. So I've got 2 variables already sorted now. So now I've got those, I can plug those into one of these first equations and get beta. Well, the first one has just got a single beta. So let's use equation 1. So I've got 4 equals 2 times alpha. So that's 220 over 53 plus beta plus 3 gamma. So plus 3 of those, well, that's a minus. So if I times 85 by 3, I get 255. So that's minus 255 over 106. Okay, right. Let's get everybody over 106. So now I get 4, turning that over 106, 4 times 106 is 424. So 424 over 106 equals, times that by 2, 440 over 106 plus beta, just leave that as it is, and then minus 255 over 106. Okay, well, I'll get these two over this side. So now get everybody over 106, common denominator, 424 minus 440, and then add 255, and that equals beta. So therefore beta, 424 minus 440 is minus 16, plus 255, that gives me 239. 239 over 106. So that gives me my beta. Okay, now let's plug in and let's just see what happens. So let's plug it into this one. So let's just test what we've got here. So we got 7 equals 4 times alpha. Alpha is 110 over 53, so that's 440 over 3. 440 over 53. So bear in mind I'm going to use this one. Minus 2 times beta. Beta is 239 over 108. So times that by minus 2, we get minus 478 over 106. And then minus 4 gamma. So minus 4 times minus 85 is plus 340. And that's over 106. Okay, right. Change this one and get this one over 106. 7 times 106 is 742 over 106 equals 880 over 106 minus 478 over 106 plus 340 over 106. Okay, 742. Can we get 742 out of this? So 880 plus 340. Well, 880 plus 340 is 1,220. 1,220 minus 478 gives me 742, and that is tested. So that's good. So therefore my linear combination of these, I can substitute my alpha for 110 over 53. My beta will be 239 over 106. And my gamma is minus 85 over 106. So I'll write minus 85 over 106. And with all the rain outside, which is what we can hear right now, that's my linear combination of this vector here. Okay,